Hi folks, it's Friday, 11/22, November 22nd, and hopefully you read your announcements today, and unfortunately, I am sick, and I was starting to feel pretty miserable yesterday, but I had a rough night. You'll probably hear me sneezing several times in this video, and I do apologize for that. But I thought it was best to stay home today as to not expose all of you to germs. So I'm here this morning, well before the sun is up, making this video in preparation for your class today. So let's get to it. You need your calculator today, although I don't really think that today's lesson needs a calculator, so I think you'll be fine without that. You will need your purple packet out. Hopefully you have submitted your Big Ideas Proportional Relationship assignment. If you have not done that, when we get to work time today, do that first instead of assignment 54, and then do assignment 54. I think you might have time to get both items done in class. Maybe not all 53 and all 54, but if you have 53 done, we should be able to get through this video, and then you should be able to watch or to complete assignment 54 before you head out for the weekend. Okay. Also, you need to submit your IXLs, number 12, right now. Even if you are not done, you need to make that submission. And when you get done with the notes today, you could go back and update those before you start working on assignment 54. That might be a good idea. Today's assignment is going to be in your Big Ideas textbook again after we finish page 11 and 12 of notes. So let's get to it. I'm going to play this slope intro video right now. Hopefully this works and you can hear it.
What's up, everybody? Let's go ahead and jump into this introductory lesson on slope. Now, what makes a roller coaster fun is that you are constantly changing direction, whether you're increasing or decreasing at different levels of steepness. And we are going to relate this experience to our understanding of the slopes of lines on the coordinate plane. So we are going to think of the slope of a line as its direction and its level of steepness. Now, portions of a roller coaster with a low amount of steepness result in a slow and gradual change in elevation, while the sections that are very steep result in a rapid change in elevation. So as long as you're not feeling too nauseous, let's go ahead and extend this thinking to our understanding of the slopes of lines. Now, in this lesson, we're going to discuss two types of slope, positive and negative. Now, positive slopes increase from left to right, while negative slopes decrease from left to right. We will also be referring to slope in terms of what we call rise over run. So we have a line with points on the line. Now the rise is going to represent how many units up or down we have to move, and the run is going to be how many units left or right we have to move in order to move from point to point. And it kind of makes a staircase image. Now notice that since this line has a positive slope, our rise was upwards and our run was to the right to move from point to point. However, if our line has a negative slope, that is, it decreases from left to right, when we rise downwards. I know that sounds weird, but we're rising in a downwards direction and then running over to the right to move from point to point. So let's take a few moments to visualize the difference between applying rise over run to positive and negative slopes. Again, notice that the line with the positive slope is increasing from left to right, and that the line with the negative slope is decreasing from left to right. Now we can go ahead and take a look at a line on the coordinate plane. Now we want to find the slope of this line in terms of rise over run. So our slope is going to be expressed as a fraction of two numbers. So our rise is the amount of change we go vertically. Our run is the amount of change we have horizontally as we move from point to point. Now this is a positive slope. We can tell by looking at it. It increases from left to right. And we're going to start with the two farthest points away from each other. So we'll start by counting the rise, number of units that we are increasing, and then the run, the amount of units that we're moving horizontally, again, to make this staircase shape. If we count the number of units upward, we rose 12, and then our run was 18 units to the right. So we can express our slope as positive 12 over 18. However, 12 over 18 can be simplified. If we divide those both by 2, we get 6 over 9. That means that if I start from the same point and this time rise 6 units, and then run to the right 9 units, I'll still end up on the line. It's a different point. So this is a more simplified slope, but if I repeat that by rising 6 and running over to the right 9, I do end up in the same spot. So when we find the slope of a line, we always want it in the most reduced form possible. Now 6 over 9 is smaller than 12 over 18, but that can actually be reduced again. 6 over 9 is equivalent to 2 over 3. Now we notice that if we start again at that same point, rise up 2 units, run to the right 3 units, we end up at another point. And this time it's the closest point. And if we continue that pattern by rising 2 and running to the right 3, we're slowly building that staircase, but we're also landing on a point on the line each time. So the most reduced form of the slope of this line is positive 2 over 3. Now again, that doesn't mean that the other two slopes, the 12 over 18 and the 6 over 9, were incorrect. They just weren't in reduced form. But all three of the slopes that we looked at will take you from one point on the line to another point on the line. So here's our first example. We want to find the slope of the line that passes through the given points that are shown on the graph here. Now we know that slope is rise over run, so we want to find the rise over run between those 2 points. So let's go ahead and build our staircase. This line has a positive slope, so I'm going to rise up a certain number of units and then run over to the right to get from point to point and then count. My rise is 6 and my run is 3. Now I'm almost done, but 6 over 3 can be reduced because 6 divided by 3 equals 2. And we want to think of slope as a fraction in terms of rise over run, so we're going to express it as 2 over 1. So if we go back to the starting point, if we rise 2 units up and run to the right 1, we end up on the line again. And if we continue this, rise over run of up 2 and going over to the right 1 and building that staircase, we continue to land on points that are on the line. So the slope of this line in reduced form is 2 over 1, which we are just going to express as 2, since 2 over 1 means 2 divided by 1, which just equals 2. This last example is just like the last one, except now we're dealing with a different line. Now notice that this line decreases from left to right, so its slope will be negative. So now we want to find rise over run between those 2 given points. Since the slope is negative, we rise downward, and then we run to the right to make that staircase image. And then we can just count. So the rise downward was 3 units, and the run to the right was 8 units, so the slope of this line is negative 3 over 8. Which cannot be reduced, so that's going to be our final answer, the slope of this line. Cool, cool. Thank you so much, guys, for checking us out. Please subscribe to our YouTube channel for more free animated math lessons updated.
All right, so as you saw there, we are going to be looking at lines and analyzing lines. And part of the reason we are doing this now, when we've just come out of the proportional relationships, is because this concept of slope that we're going to study today and Friday, or today is Friday, today and Monday and Tuesday, is a proportional relationship, because that rise over the run is what we like to call a constant rate of change. And that rate of change is the definition of slope. It's going up the same every time and over the same every time. And your job today, our job today, is going to be to find that. Okay, so as you can see in your notes, let's get to page 11. If you're not already there, we We have our fun little cold bird here giving us some pictures about direction of lines. Okay, today is November the 22nd, if you want to record that at the top of page 11. And so, as you can see, we have 4 kinds of slope. Okay, 1 and 2, positive or negative. And then 3 and 4 are zero slope. I like to always tell people this is a flat line. This is what you want your bedroom to be. The floor of your bedroom, the floor of anything you're walking on is much nicer when it's zero slope than an inclined slope, positive, or a declined slope, negative. And then we have a vertical line, which is undefined, not possible. So I already said that over here. This one is horizontal. And this one is what we call vertical. So some special terms there on those pictures. All right, so he explained it in the video pretty well. Here is a 4-step process, and we're going to go through that. So you choose any one of the points. The hardest part, and this is why I hate not being here today, but I'll be here Monday to kind of help you again see it, is kids are always coming up to me and saying, which points do I choose? Which points do I choose? My friend chose this. I chose that. I don't know what to choose. Here's the key. It doesn't matter. You can choose any 2 points you want. As long as you calculate it accurately, you'll get it right, even if you choose 2 different ones. So here you have a picture, point 1, point 2, and you're going to draw this little stair step lightly. Do not make it part of your graph. And you're going to figure out how much did I have to go up, 2, over how much did I have to go over, 3. Draw the rise, draw the run, count those numbers, and that is your slope. Now, if you're looking at this picture, I drew those for you. Let me change colors here. But I could have drawn this point and this point way up here. And I could have drawn this. Okay, and if I did that, it would have been up 4 over 6. And so kids were like, I got a different slope. What is wrong with 4 over 6? 4 over 6 is not simplified. It comes down to 2/3. Please always pick the farthest to the left point and move right. Okay? Every year I get a kid or 2 who's looking at it backwards and they want to start right here and go this way. Okay, if you do that, you need to understand that would be down 4 and left 6. And what does negative 4 over negative 6 equal? Positive 2/3. We can avoid that mess if everybody starts on the right. Start as far, not right. Everybody starts on the left. Start as far left as you can for your first point. And then you're going to move up or down. Obviously, if you move up, it's positive. If you move down, it's negative. And then you're going to move to the right to get to your next point. It's like giving directions. Up 2 blocks, over 3 blocks to get to the next intersecting point. So let's turn the page over and let's look at a few on the back. With number 1, we're going to start here at the origin. We're going to travel to this dot right here. I've highlighted them in orange. And we're going to name our travel. So we're going to go up 1 and over 2. So my slope, remember, it's always rise over run. That should be easy to remember because it's y over x. And we've been doing y over x for the last 4 days in this class. So my y change is 1. My x change is 2. That means my slope for number 1 is 1/2. And again, I can see that in several places on this line. From here to here, up 1 over 2. From here to here, up 1 over 2. From here to here, up 1 over 2. I can go from here all the way to here. Right here to right here. That would be up 1, 2, 3, 4, and over 8. And what's 4 over 8? Hopefully we're all following along. That would all be 1/2. Number 2, again, start as far to the left as you can. And we're going to travel from that point to this point. So hopefully everybody can see this one has got to be negative. It's going down. How many am I going down? I'm going down 2 and right 2. So that means my slope is -2 over 2, which means my slope is -1. That means I should have been able to go down 1 box and right 1 box and hit the line. Could I have done that? And the answer is yes. Down 1 box, right 1 box would work there. You try 3 right now. Pause the video and try 3 by yourself. And restart it once everybody has a value there. Okay, I'm going to start as far left as I can in that orange dot, and I am going to move to the green dot. And from the orange dot to the green dot, I'm going to move up 1 and over 2. So this line has the same slope as number 1. Now notice they're different lines. Number 1 is a proportional relationship because it went through the origin. Is number 3 a proportional relationship? Hopefully you're all saying no, but it still has the same slope of up a unit, right 2 units, up a unit, right 2 units. And number 4, again, I'm going to start up here at the green dot, and I am going to move towards the orange dot, and I'm going to go down this many, 1, 2, 3, 4, 5, and I'm going to go over 4. Slope is m. M is going to be -5/4. Slope's universal label is m. We'll talk more about that on Monday. If you don't write m equals, I'm not going to count it incorrect, but you'll start seeing that more and more. Let's go to number 5. Now, if you look at the front page of these notes, or back on page 11, you should know what kind of, what the slope is of this one automatically, because this is a special one. Number 5 is a special one. Number 8 is a special one. Anytime you have a flat line or a horizontal line, and I try to do rise, there is no rise. It stays the same. That means my slope is 0. Slope is 0. Number 6, start on the left. Moving from this point to this point up here, you're going to count the boxes. Up 4 over 1, my slope is 4 over 1. That should be simplified to just 4. And again, before you ever start one, you should look at it and say, okay, is it going to be positive or is it going to be negative based on what you're seeing there? Hopefully you're seeing, oh, that one's going up, or oh, that one's going down. If it's going up, then you know a positive line, like in number 6. Before you ever start, you should have been saying that's going to be a positive. In number 7, before you ever start, you should be saying this one's going to be negative. I'm going to be going down 1, 2, 3, 4, and I'm going to be going left 2, so -4 over 2. That does need simplified. Simplify that down to -2, which again means I could have went down 2, right 1, and hit it. Down 2, right 1, down 2, right 1, down 2, right 1. And as we said, number 8's the other special case. This one has a lot of rise. I could count infinite rise. But this one has no run, which when you think about the fraction rise over run, if this is a 0, that breaks one of our number 1 rules. We've talked about that in different units. Can you divide by 0? That's the number 1 rule in the back of the room. No dividing by 0. That's what makes this one undefined. It's not possible. It doesn't matter how many you're going up. You can go up as many as you want. You cannot have 0 on the bottom. Impossible. All right, the next set of 3, every time I tell kids to go do these, everybody freaks out. And guess what they say? Mrs. Kearns, there are no points. Okay? There are no points. If there are no points in the graph, that does not mean you can't find the slope. What it means you're going to do is pick some points. You can pick any points you would like. Just remember, you got to have 2. And if you're going to have to count rise and run, why not pick 2 easy points to get there for the rise and the run? So I am not going to pick this point right here in blue. That's not an easy point to count. I'm not picking this point right here in blue. Not an easy point to count. I am going to look for some points that are at clear intersections that I can then count very easily. Like this point, I'm going to put it in red. And I'm going to use this point right here. So, given those 2 points, I'm going to start on the left, and to go from this one down here at -3, I'm going to go up 1, 2, 3, 4. And I'm going to go over 1, 2, 3, 4, 5. So my rise is 4, my run is 5. My slope is 4/5. Positive number because it was positive picture. Number 2 is a negative number, so when you are a negative slope, so when you get your answer, you better make sure your answer is negative. Let's find some points that will work. I think this point works right here at -2, 0. And I'm gonna probably, go with this point right here, I think. So from here, I'm going to go down 1, down 2, down 3. Oh, down 3, not this part. Down 1, down 2, down 3. And I'm going to go right 1, 2, 3, 4, 5. -3, because I went down, 5ths. And number 3, this is an easy point to fix. And I'm going to go way up here to this one. I skipped a lot of them that were very close, so I want to draw your attention to the close ones. Back here, this was close. This was kind of close. You want to get as close as possible. That's not close enough. Not close enough. Close as possible. Look all the way through. Here, I'm going to go up 1, 2, 3, 4, 5. And I'm going to go over 4. My slope here for number 3 would be 5/4. All right, last task, and this is a preview for Monday, but this task says to graph some points and draw the line. Now, to do this, you're going to need a straight edge. That can be the edge of your iPad, can be an edge of another piece of paper, your binder, a folder, something straight. I'm going to plot 0, 0. That's at the origin. Hopefully everybody remembers that. And I'm going to go to 5, 8. So that's over 5. Remember, in an ordered pair, first number's left and right, second number's up and down. So over 5, and I'm going to go up 8. And then I'm going to take a straight edge and I'm going to draw that line. This is very important that you're using something straight. Otherwise, you sometimes end up with something that's not working. Let me get a different ruler. My iPad did not like that ruler. So it's a magnet. Here's my line. Right near my slope answer blank. Now I'm going to find the slope between these 2 points. To go from here to here, I went up 8 units, and I went right 5 units. My slope is 8/5. Do not make it a mixed number. Reduce it. Don't make it a mixed number. For number 13, pause the video and give it a shot. When you're done and everybody's done, restart the video. To find the slopes between these two, I would say to go from this point here to the blue point, I would go up 1, 2, 3, 4, up 4, and over 4. So that means my slope would be 4/4, and I am going to reduce that. If it reduces to a whole number, that's fine. You just have to remember that means it's over 1. And that works. Okay, we'll be doing this on Monday when we have some graph paper and maybe some marker board activities where we'll be plotting them as part of our assignments. Today you're just going to be doing the counting stuff. So you're going to be navigating over to your big ideas. You're going to do the assignment called Finding Slope. There's no work to show because you're going to be counting on your iPad. You do need to use the check feature. All you have to do is submit a screenshot to Canvas. Make sure your name and assignment title and score are in there. If you finish early, and like I said, you might, you should spend the rest of the period in IXL. Either updating your IXL for the week, completing missing IXLs from weeks past, or working on your recommendations. You have a plethora of items in there that you can be doing. I hope to be back on Monday. Sorry I was out today. I hope you have a great weekend.